Okay, so like we said, first unit here, guys, is kinematics. So we're dealing with fairly simple motion. Everything we do today is going to hopefully seem familiar to you, okay, from Science 10. All right, so kinematics is the branch of physics that describes the motion of objects without referring to the forces, work, energy, etc. that causes it. Okay, just looking at the mechanics of it, essentially. Okay, the dynamics part. Okay, dynamics and mechanics go a little bit more together in that they're dealing with the forces and energy, etc., that cause the motion to occur. Okay. So typically, when I'm teaching a lesson, okay, it'll match up with the notes package. There'll be a lesson number, okay, which is the one you need to find. Okay, and then there'll be some key points, which are also in your notes package. Okay, the key points are the things you would probably want to come back to when you're reviewing. Okay, they're the most important parts of that lesson. They're going to be the things that show up on a quiz or a test later on. All right, so the key points for today: understand that the motion of objects and systems can be described in terms of displacement, time, velocity, distance, speed, okay? All of these kind of quantitative measures of the movement of an object, okay? We need to look at, or kind of review, okay, scalar versus vector quantities. Okay, anybody remember the difference? Right. Okay. Vector quantities include a magnitude, so a measured value, and a direction. Okay. Whereas scalar quantities are just a measured value. So my mass is a scalar quantity. It's just a number. Okay. It's not this many kilograms left or right or down. It's just how much of me there is. There's no direction to that. Okay. Whereas my weight, which is different from my mass, is a vector quantity. Okay? It's how hard gravity pulls downwards on my mass. Okay? That's a vector quantity. Okay, so magnitude and direction. What we'll look at today is like distance versus displacement. One of those is scalar, one of those is vector. Speed versus velocity. One of those is scalar, one of those is vector. They describe similar things, okay, from different points of view. Everybody heard that idea? Sound familiar? All right, and then lastly, defining velocity as a change in position during a time interval. In other words, this formula from Science 10, velocity is displacement divided by time, which is also the same as saying my final position minus my initial position divided by time. Okay? Incidentally, those little things that are above the V, above the D, above the P are little arrows that indicate these are vector quantities and have both magnitude and direction. Okay? I could also write this. I'm not crazy, that's different. Okay?
Isn't that speed?
Yeah.
Because you're looking at their distance or the
Right. Speed is distance divided by time. Okay? These are scalar quantities. Okay? There's a difference. Okay? The biggest difference would be if you got pulled over by the police on Deerfoot Trail and the officer walks up and says, "You know how fast you were going?" Does he want your velocity or your speed? Speed. Okay? You tell him 130 kilometers per hour, officer, I'm very sorry. Okay? If you reply with 130 kilometers at 10 degrees west of south, he's going to ask you to step out of the car and ask you if you've had anything to drink today. Okay? Make you walk the line and perform some field sobriety tests, because that is an unusual answer to that question. He is not looking for your velocity, which is a vector quantity. Okay? All right. Now, on that note, the way that we describe these kinds of quantities in real life is really messed up, especially in North America. Okay? Now, some of you are in my Science 10 class, so I asked you this question last year. But if I were to ask you how far it is to Edmonton, what are you thinking right now? Okay? Pretty rare to get that answer. 400 kilometers.
People usually say like time.
Exactly. Okay? In North America, we default to how long it takes. That's not what I asked. I said, how far is it to Edmonton? But probably 9 out of 10 people, or even more, would tell you it's about 3 hours, 3.5 hours. Okay, which is not the right answer. That's how long it takes, not how far. And how long it takes is dependent on how far and how fast. Exactly. Okay? Yeah, I've gone to Edmonton lots of times, sometimes in less than 3 hours. Sometimes 10 hours. You get caught in a blizzard and there's an accident, you get diverted off to the other 2-lane road, you know, whatever. Like, honestly, we had one time where we came back from West Edmonton Mall on a physics trip, and it was 10 hours. Like, we got back at like 3:30 in the morning, okay, because it was a blizzard. That happens, okay? It isn't always 3.5 hours to Edmonton, but it's always 385 kilometers, as long as you start here. And that doesn't change. And unless, you know, the continent cracks open or, you know, something, okay, it's always the same distance from here to there. Okay? So we have to kind of get our head around that a little bit, because we've been brought up in a culture that does that. Okay? You don't see that in all cultures. Okay? In Europe, if I was to ask you how far it was from, I don't know, like Pisa to Florence, they would tell me how many kilometers it is. Okay? Because they use a variety of different ways to get from place to place. Car, train, bus. Okay? They use a variety of different ways. They're much more likely to give me an actual distance measurement than in North America. It's just a cultural thing, so we have to be prepared for that. We have to know that when a question asks how far, that we're supposed to give a value in meters, kilometers, centimeters, something. Okay? If I asked you how far and in what direction it is to Edmonton, then you'd give me not only the straight line, but also which way to go. Okay? Then I could fly there in a helicopter. Okay? In a perfectly straight line. Everybody okay with that idea? Okay. So, if you've ever gone hiking off trail, done any orienteering, you know the way we typically describe things, distances in North America, is only good at getting you hopelessly lost or frustrated. Okay? I had a time where I was backpacking with a friend of mine, and we thought we had gotten lost because we knew or had a pretty good idea how far we'd gone, we thought, but we certainly knew how long we'd been on the trail. And it was a lot longer than we thought it should have been. Both of us were physics teachers. This is the embarrassing part of the story. Okay? And so we sat down and we're looking at the map, and you know, we haven't eaten and we're out of water. You know, certainly make those bad decisions. And we see this guy come like running up the trail towards us. Okay? We didn't really notice or think about this at the time, but he was wearing like army fatigues and carrying a really heavy pack and running uphill. And we're like, hey, like, dude, did you come from Tumbling Falls Campground? And he's like, oh yeah, mate, it's like down the trail like 20 minutes. And I'm like, sweet, 20 minutes. An hour later, we stumble in to the campground. And we are cursing this guy, and we are so dehydrated and hangry that we are talking about how we're going to hunt him down. Not thinking about the fact that it took us an hour to walk downhill to this place, and it took him 20 minutes to run uphill from it, okay? Because he was probably special forces and just out for a training run with his heavy pack, okay? We're two out-of-shape teachers on their summer vacation who should have known better than to accept 20 minutes from a guy who was in way better shape than we were, okay? He should have told us that it was still 3 kilometers down the trail to where we wanted to go. He was way faster than we were. It's things to think about. Okay? Now, there's a couple of different ways that we can describe how far something is. We can use distance, which is scalar. And that's what we default to most of the time. Because, at least in most situations for us, there's a road to follow. Okay? And you just say, oh yeah, it's 100 kilometers from here. Or there's a sign on the side of the road that says, Okotoks, 25 kilometers. Okay? And it just takes for granted that you're going to follow the road. Okay? Is it actually 25 kilometers? Not in a straight line. In a straight line, it's probably less than that. But if you tell someone that it's this far in a straight line, you also have to tell them what direction to go. Okay? Because if you don't, how many choices do they have?
360.
360. Right? In any direction, they can pick it. Okay? That's not going to work out very well. Okay? So there's scalar quantities, there's time and place for those, and there's vector quantities. There's time and place for those. Okay? It doesn't make one always better than the other. It's very situational. Okay? A road sign, it's appropriate to use a scalar quantity. Okay? Because it implies I'm going to stay on the road. Okay? If I'm the captain of a cruise ship and I'm going across the ocean from one place to another, that's not a time for a scalar quantity. Okay? I need to have a heading for the boat, I need to follow that heading, and I need to know how far it is in a straight line. Okay? Same if you're a pilot. Okay? I need to know what heading do I need to go on and how far do I need to go on the heading. All right. So does that make sense? Difference between scalar and vector? Okay, so vector quantities are more descriptive. They give more information. Does that make them more accurate? I actually see more people nodding no. That's good. Okay, because oftentimes we get the idea that more information means more accurate. Okay, but it's actually not the case. Accuracy is dependent on how you measure something, not whether it's scalar or vector. Okay, if I say that to get to the airport from here, what is that, 65 kilometers, let's say, if I follow a Deerfoot Trail from here to the airport, okay, it's 65, actually let's be really accurate, let's say it's 65.15 kilometers, okay, or I say that it's 58 kilometers at 13 degrees east of north. Okay? The top one is a scalar quantity. The bottom one is a vector quantity. Which one's more accurate? The scalar quantity. It's measured, okay, to plus or minus 10 meters. This is measured to plus or minus 1,000 meters. Okay? This is only accurate to the nearest kilometer. Okay? It's somewhere between 57 and 59 kilometers. Okay? This is somewhere between 65.14 or 65,000. No, I got that wrong. It's plus or minus 100 meters. Okay? Sorry, not 100 meters, 10 meters, plus or minus 10 meters. Okay? It's much more accurate than this one is. Everybody okay with that? Okay, if I said it was 156, then it'd be plus or minus 1 meter. Okay, that'd be really accurate. Okay, so accuracy depends on how you measure something, not whether you give a direction or not. Right. It would be like if I sent one group out with a meter stick that had like to the nearest millimeter and told them to measure one side of the track, and then I sent another group out with a meter stick with no markings on it. You're going to measure it exactly the same, but who's going to be more accurate? Yeah, the meter stick with all the markings. They can tell me to the nearest millimeter how long that is. Okay? The other group can only say, well, I got the stick to here, and I don't know, it was like a little more than one stick left. Right? Like you can't be as accurate. You can only be accurate to plus or minus the length of the stick. Okay? All right. So, a simple trick looked at from both a scalar and vector perspective would go something like this. So let's say I want to go from my house to like Walmart or Home Depot or something like that. I just want to walk from my house to somewhere else. Okay? Unless I live like right next to the store, can I walk in a straight line? No. Okay? I have to, go around fences and trees and follow the road and whatever else, take the bridge across the river, and stuff like that. So this black line here would be the actual route that I follow from my house to the store. Okay? Let's say that it's 4 kilometers. Okay? So by the time I've walked from my house to the store, I've gone a distance of 4.0 kilometers. Okay? That's a scalar description of that trip. I've only actually changed my position or displaced myself by the purple line. Okay? Same trip, but this is a different perspective now. It's looking at it from the straight line vector perspective. Okay? That displacement is 2.8 kilometers at 38 degrees north of west. Okay? It's different. It's the same trip, but it's a different perspective. Okay? That is how much my position has changed by, not how far I've gone. Okay? I know it kind of seems like it's the same thing, okay? But it's not. Right? Because I had to go a whole bunch of different directions along the black line, okay? That doesn't account for my change in position from start to finish. Okay? That's always going to be a smaller number or an equal number if I was actually able to travel in a straight line. Okay? All right, so those are different. Now, let's say that that trip takes me a half an hour. What's my speed? How fast am I going? I walk 4 kilometers in a half an hour. 8 kilometers per hour. Okay, that'd be my speed. Okay, speed is distance divided by time. 4 kilometers divided by 0.5 hours is 8 kilometers per hour. Okay, what's my velocity? Good, that one has a decimal in it, I can't do it in my head. Okay, velocity is displacement divided by time. Okay, 2.8 kilometers at 38 degrees north of west divided by 0.5 hours. Still took me half an hour to change my position by that much. I didn't actually walk the purple line, okay? But that's what I did. Okay? That means that my velocity then is 5.6 kilometers per hour at 38 degrees north of west. Is it important that the vector is the same for both velocity and displacement? Why do we need to square it?
Your final position.
Why does that need to be squared?
Because like last year, wasn't it PF squared subtract PI squared?
No, I think you're thinking acceleration.
Okay.
Yeah. Okay. So it's important that the direction's the same for this reason. If I travel east, due east 5 kilometers in 1 hour, can my velocity be anything other than east for that trip? It can't. That's where it went. My velocity is a function of how far and how long. They have to have the same direction. Okay? I can't travel at 100 kilometers per hour north and end up 10 kilometers east. Okay? It's not possible. The two are dependent on each other. So they're always going to have a matching vector. Okay? I'm old and forgetful. So by the time I get to the store, I've walked 4 kilometers, I walk in and I go, I forgot my wallet. Because that's never happened. Never. It's not at all why I put my card information on my phone, which I also forgot. Yeah, okay, so I get there and I have no way to buy what I came there for. So I just turn around and walk home along the exact same route. Okay? When I get home, it's been exactly 1 hour since I left. What's my total distance traveled? 8 kilometers. What's my average speed over the whole trip?
Zero.
Speed.
8
8 kilometers per hour. I traveled 8 kilometers in 1 hour, 8 kilometers per hour. Now, what's my total displacement over the whole trip? Nothing. Yeah, exactly. Displacement is my change in position from the start of the trip to the end of the trip. Start of the trip and the end of the trip are my house. I haven't changed my position at all by the end of the trip. So my displacement is 0. What's my velocity? You were right. Yeah, it's also 0. I mean, the velocity is displacement over time. My displacement is 0. My velocity is 0. I can't have a rate of change of position if I haven't changed my position. Okay? That's what velocity is. It's the rate of change of position. Okay? If I haven't changed my position, then there's no change in velocity. Okay? That's where the two get different, right? It's the same trip, but now I'm getting very different numbers. Okay? One is saying nothing happened, because from a vector point of view, I accomplished nothing. Okay? Well, from a lot of points of view, my wife would agree. I accomplished nothing. I went to the store to get something and I didn't get it. Okay, came back and there was nothing there. Okay? So yeah, it's two different points of view. Okay? Now, on your car, you have this little thing called the odometer. Okay? Does it tell you the distance your car has gone or the displacement your car has gone? Distance. Okay? Why is that important?
It's how you use your engine.
Yeah, it tells somebody how far you've driven the car, how much you've used the car, unless you're in stop and go traffic, and then it might also be good to have an hour gauge to tell you how many, and actually on most modern cars, it also tells you the engine hours, how long the engine has been on for, okay, which is also, important. So yeah, those are important metrics for telling me how used a car is, okay? If that gauge doesn't read distance and reads displacement, what is it going to read when it's in my garage every day? No. It's going to read how far it is from the dealership I bought it at to my house. Trashed. Very rarely do I ever get the right answer. Everyone goes with 0, which logically makes sense. But yeah, if it read displacement, I'd be able to sell that car like it's brand new. Okay? Because it would always say some really tiny number, or take it to the dealership and go, I want to trade this in, it's brand new, 0 kilometers on it. Okay? Yeah, that's not very useful. Okay? Dishonest, in fact. Back in the day, people used to roll back. They had the actual mechanical odometers. They weren't digital. They could take the thing off and roll them back. So the thing could have 500,000 kilometers on it, but they just go tick, 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 and now it says like 200 kilometers. So, yeah, there's an appropriate use for certain types of quantities. Okay? There's not one that's always better than the other. It's totally situational. Which thing would be more not accurate, which would be more appropriate for each situation. Okay? Does that make any sense? Okay. All right. In this situation, let's say I'm here at Seldom Inn Campground, and I want to walk to Snake Indian Falls Campground. The little dotted line is a trail. There's a sign outside of Seldom Inn Campground. Does it tell me distance or displacement to the next campground? Distance. What does it assume? Then I'm going to follow the trail. Okay? That's the appropriate measure for that situation. Okay? Because if I do this, okay, that's going to be hard. Okay, like every little squiggly line is a river, so there's probably a canyon, and if I'm not on a trail, there's no bridge. Okay, this gray stuff is a glacier, so like that's not the smartest way to go. There's a reason the trail goes this way. Okay, that sign does not say Snake Indian Falls Campground, 19 kilometers at 49 degrees west of north. Okay, that would be the compass heading I would use if I was flying a helicopter, right? This would be about 49 degrees, okay? It's west of north, okay? It would be accurate, but certainly not appropriate. I wouldn't want to go that way, okay? Then that's bushwhacking all the way, and it's not going to work very well. Okay, that sign does in fact say Seldom Snake Indian Falls Campground, 31 kilometers. Okay, implying follow the trail, stupid. Okay, because otherwise you're going to run into all kinds of problems. All right, making sense? Okay. Does it sound familiar? Here, my science tech classes sound really familiar. Okay, so just terminology here, okay? Scalar quantity, okay, speed, okay? Speed is a measure of the rate of change of distance, okay? How fast you're going, in other words, okay? Kilometers per hour, meters per second is probably the one we use most often in physics, okay? But it could be any distance measurement over any time measurement, okay? Velocity, okay, is your rate of change of position. So that's going to have not only something in meters and something in seconds or hours or whatever, but also a vector, okay, attached to it. Okay. All right. So, scalar quantity is a measured quantity that only has a value, 4 kilometers, 75 kilograms. It's time. Is time scalar or vector? That's confusing, right? Because here's another thing we do in society. How far is it to Edmonton? Ah, it's 3.5 hours north of here. Did I just make time a vector quantity? Time can't be a vector quantity unless you know something I don't, okay? Like, if you got a time machine, good for you. That could be really useful. But as far as we know, time is fairly linear, and it goes one direction, forward. Okay? You can't go back in time. You can't go left in time. Okay? You can only go forward in time. Time is a scalar quantity. It simply passes. Okay? We cannot give it a direction. Okay? But we say things like that. Right? Ah, it's like 10 minutes west of here. No, it's not. It's some number of meters or kilometers west of here, but it's not like X many minutes west of here. Okay? Time is a scalar quantity. So distance is a scalar quantity, okay, it measures how far an object has traveled. Speed's a scalar quantity, measures how far an object travels in a set time interval. Okay, vector quantities have both value and direction, so a measured value and a direction. 40 kilometers forward, okay, 32 kilometers, 18 degrees west to south, 600 newtons down, okay, something like that. Okay, force, which is what newtons measure, how hard something pushes or pulls, that's a vector. Right, displacement, okay, vector quantity that measures how far and in what direction an object has traveled from its starting position, okay, and then velocity measures the displacement or rate of change of position. Okay. All right, everybody okay with those? Formulas look familiar? Okay, we're just going to kind of work on a few kind of practice problems to review use of V equals D over T, okay, that kind of thing here. So. Okay, so this one's a fairly straightforward one. I wouldn't have you write it down. Okay, we'll just kind of do it as an example here. So this person starts here, 1.5 meters to the right of this Inukshuk. Okay, so this is their initial position. This is their final position. Okay. So their final position is 3.5 meters left of the Inukshuk. Okay. What's their displacement if they walk from their initial position to their final position? 5 meters. Right, their displacement is 5 meters left. What's their distance traveled? 5 meters. Okay, same trip, different points of view, but same magnitude because it was a straight line. Okay, everybody all right with that idea? Okay, so we often calculate displacement by simply doing this. We take the final position and we subtract the initial position. Okay, my final position is left. My initial position is right. How do I represent those opposite directions mathematically? Positive and negative. Okay, so this looks like this. Negative 3.5 minus positive 1.5, which is negative 5 meters. Okay? Now, if that was a question on a quiz, would you leave it as negative 5 meters, or would you write 5 meters left?
Negative
What did the question give you? Left and right. What should your answer be? Left and right. Your vector should always, you have to represent your vectors positive and negative when you're doing any mathematical operation. But you have to go back to whatever that negative represented for your final answer. The final answer is actually 5 meters left. That's the direction that was given in the question. Okay? So it's like basics of using vector quantities. Okay? Okay. All right, I would like you guys to try, it's a little bigger so it's easier to read. I would like you guys to try question numbers 1 and 2 right now. Okay? Give you a few minutes to try question 1. You can. Okay, let's have a look at these first two here. So the first one's pretty straightforward because all the directions are north. They're all the same. So okay, it's a straight line. Okay, the displacement's going to be 40 plus 20 plus 100, so it's 160 meters north. Okay, pretty straightforward. If we were going to represent that visually, okay, then we would have like 40 meters, 20 meters, 100 meters. That's what their trip looks like. Still ends up being 160 meters north. Okay, now we're all right with that. All right. Now, for the next one, sometimes people get confused on this because they actually do what I often tell people to do, which is visualize what this person is doing. Okay, so they're imagining a basketball player, they're holding the ball, and they fake out the defense by going this way, and then they actually go from there 3.5 meters the other way. But for someone like me who's played and coached basketball, I see that that person's pivot foot hasn't moved. And I assume that, like a bunch of times when I'm doing this question, I'm like, yeah, well, their displacement's 3.5 meters to the left because that foot didn't move. Their center did. Okay? Their center went from this position, 0.75 meters over here, and then from this position, they went 3.5 meters to the left. Okay? So if I'm drawing this out visually, okay, I would go, all right, 0.75 meters to the right, and then from there, 3.5 meters to the left. What's their total displacement now?
2.25 meters to the left.
2.75. 2.75, right? 3.5 minus 0.75.
Oh, yeah.
Right? Because this was their initial position. Okay? That initial position isn't 3.5 meters away. It's 3.5 meters from this spot. Okay? So we go back to that. All right, they went to the right 0.75 meters plus negative 3.5 meters. Okay? If I'm talking about what happened on that trip and assigning positive and negative to the vectors, I end up with negative 2.75 meters or 2.75 meters to the left. Okay? Everybody all right with that? Okay. Try number 3. This is an important one to visualize. Okay? The person has a trowel in their hand and they're starting right here. And they're doing all this troweling back and forth. Okay? Give you a couple minutes on that one. All right. So each time she goes out and back or back and forth, that's 1.7 meters total distance traveled. She does that 4 times. The total distance is 6.8. 1.7 times 4. Okay? So she moves her hand 6.8 meters in total. But she goes back and forth 4 times. Where does her hand end up? Back where she started. So her total displacement is 0. Okay? Anytime your final position and your initial position are the same, your total displacement is going to be 0.
If displacement is 0, what do you put as a direction? Nothing.
Nothing. You can't give a direction if no position changes it.
Yeah.
That's a good question. Okay. Any other questions on that? Okay, I think we'll leave off there. There's about 3 minutes left in class, but it's not enough time for us to get into another one. Okay, so for Friday, okay, have made your decision about what you're going to do with your notes and workbook packages. Okay, Friday we'll be continuing on with scalars and vectors, v equals g over t. It's a short class on Friday. Friday's a short day. Okay, then you got your long weekend. There won't be a quiz on Tuesday because we don't have a class the Monday before. Okay, but we will be on Tuesday moving on to more vector-related stuff, getting into probably the vector additions. Okay, not into trig, but we'll be into trig by the end of next week. Yes, there will be a quiz Thursday. Not tomorrow, next Thursday. Okay.